suppose that you are given a complex number z equal to 1 plus I. So express this complex number as a power of 20 in the standard form. So how can you make this operation? Assalamualaikum. Hi, I'm Dr. Kat. So in this lesson, you will learn about complex number in exponential form. At the end of this lesson, you'll be able to represent a complex number in exponential form. In the previous lesson, you have learned about representing complex number in polar form and also in Argand diagram. So let's start. Suppose that again we consider the complex number of z equal to x plus iy. So this is already known in Argand diagram. So without derivation, without going any further, the exponential form, which is based on the Euler's formula, is equivalent to the polar form is z is equal to r e I theta. So this is in the polar form, and the exponential form, this is the equivalent. And if we want to express the exponential form in its conjugate, it is z bar equal to r exponential minus. So this is the conjugate of the original complex number, where the change is here in a polar form. Okay, for real theta, any value of angle here, so this identity holds. So this will be useful in the next slide. Okay, for example, if you are given the complex number in an exponential form, which is exponential power by negative I pi over 3, so how could you determine the modulus of this complex number? Alright, so we can from here we can actually know that from the standard exponential form is a I theta, so that we know that r here is 1. So directly, because the modulus of a complex number is equal to r, so that we have z equal to r. So thus this is easily known. Alright. Okay, another way, which is a long way to determine the value of r, is that using the expressing this exponential form of complex numbers into the polar form. Okay, cos theta, which is I sine theta. Okay, so since this is negative, so that's why we have here negative. Alright, and then because this is just 1, we can open the bracket, then we get this polar form. Okay, and then from this polar form, we can calculate the r r value, or the modulus of the complex number, using this trigonometry using this relationship, because this is x square plus y square, right? Okay, so so from that, you just substitute this into this. So then because this is just a cos square plus sine square, regardless of the value of theta, which is equal to 1. So finally we get the same results. So that means they are consistent each other. Okay, so by this, actually what we have done is we have proven that the modulus of this value is equal to 1. Okay, so now we go to the one of the important theorem used in the complex number, which is the Moivre. I also do not know how to pronounce it. This is a French um, French name. So, okay, so suppose that you have a cos this expression power by n. So this can be expressed as the cos and I sine, but where you can multiply the number of n integer to the real angle or argument z. So this expression is called the De Moivre theorem. Okay, so for example, express this what we call the complex number into a standard form. Okay, so the standard form, what is the standard form? Standard form is x plus I y. Okay, so we want to transform this polar form into standard form. So what we can do is that because this is powered by 6, powered by 5, so what we can do is that we multiply the argument by 5. Then you calculate, then you get lastly in the polar form. Alright. So when we return to the question given in the beginning of this lesson, there are two ways that you can solve this problem, or more than that actually. Okay, so the first one, if we express the equations in the form of exponent form, okay, in the using the exponent form, so this is already calculated from the previous lesson. So here the this can be represented as 2 exponential minus 4 over 4, because this is pi over 4, and then this is just 2, right? So we can immediately use the exponential form from the Argand diagram. Okay, so and then we make a power of 20. So by knowledge of exponential manipulation, so the exponential form is very convenient to use because it is easy to be operated in mathematical way. So cert 2 is 2 power by half, right? So and it is power by 20, so that's why we get 2 power by 10. And then because this is 20 and 4, so we can also just make a cut, factorize them, so we have a 5, so that's why we get this. Alright, so 10 power 2 power by 10 is 1024, and this if we express the exponential in the form of polar form, so that actually what we get is sine 5 pi is actually 0, and then cos 5 pi 5 pi is so 0 1, so minus 1, and then cos 5 pi is negative 1, correct? So this is, so we get minus 1024. Okay, so and then if we want to use the Moivre theorem, we do not need to use the exponential form. Okay, what we can do is that in the exponential form, in the polar form, power by 20. Okay, in the exponential in the polar form, power 20, but we have to put this separately. So this separate so that we have a 2 power by 10, and then you see that now we can put into this. This is the use of the De Moivre theorem. Okay, but 20 and 4 we get 5, right? So we get these things. So you see that it is become the same thing here. So it just the same. So we can say that it is consistent. So finally we get the answer is same. So this is not minus 1. This is the answer is 1024. Okay, so you can see that you are free to use either exponential form, polar form to help us to solve a problem regarding the complex numbers.